We are going to expand using only variables. And remember, when we're only using variables, we call it a more abstract representation or a theoretical representation of what is going, what the formula is. So this is how you would derive any formula that you have in class, is that we decided to go through the whole process without any numbers. So a plus b cubed is a plus b times a plus b times a plus b. What we need to do, I want you to do, is I want you to then distribute out this multiplication, this binomial expansion, and I want you to combine like terms. I'm going to leave the first guy as a plus b, and I'm going to try multiplying the last two terms now. So that becomes a squared plus ab plus, and this one would be ba, but I really like for it to look the same because ba is the same thing as ab, so I really like for it to look the same, so it's clear to me that those guys would combine. So instead of ba here, I just wrote ab, and then plus b squared. I'm still going to have this guy for right now because what I'm going to do next is combine like terms. 1ab plus 1ab is 2ab plus b squared. And now I'm going to do my last distribution with this guy. So that's going to become a cubed plus 2a squared b. The a's multiply together here to become a squared. And then the b comes down and a 2 comes down. Plus, then a times b squared is just ab squared. Now distributing the b, that's a squared times b. And then 2ab squared. These guys multiply together, the 2 and the a come down, and then the b's multiply together to become b squared. And the last guy is b cubed. So now that I've finished distributing it all, I need to then combine like terms. So I've got a cubed plus, I've got an a squared b term, and then I have an a squared b term over here. Since there's no number in front, we know that it is a 1. So I know that this is 1 plus 2 of these terms, and that becomes 3a squared b. I've then got an ab squared in two separate situations, one of them right here and 2 of them over here. They add together to be 3ab squared. Then our final term is b cubed. So what we have done right now is create a formula for anything that is raised to the third power. If we have a binomial, any binomial that is raised to the third power, we now have a formula that we just made to use in the future. So let's practice it. We're going to use the binomial expansion of a plus b to the third power to expand this binomial. It is a binomial because it has two separate terms. This and this are two separate terms. It's raised to the third power. So if we have our formula, I'm going to write it out really quickly. And the key here is that we need to know what is a and what is b. A, in this case, is the first term in the binomial. And since 3x is the whole first term of the binomial, we know that a is 3x. The next one is a little bit tricky because it says plus b, but this guy is negative 2 minus 2y, which means that b is going to be negative 2y. Tricky. So now I get to go in and plug in everywhere I see a, I'm going to plug in 3x. I'm going to use parentheses because it's really important with exponents, and we'll talk about that in a second. But anytime you plug something in, almost like a puzzle piece, create this like vacuum in the equation and take the other piece and plug it in, right? So plus 3, and then we've got something squared, and that something is a. So 3x goes in there, and then b is going to be negative 2y. Plus 3a times b squared plus b cubed. Now I get to simplify this expression down. Realize that when I have an exponent, here it's like distribution because there's a multiplication in here, whereas above there's an addition in here. I cannot distribute that 3 to those pieces. No. But since there's no addition or subtraction between these terms, it's only multiplication. You can then distribute that 3, that cube, to the 3 and to the x. So that becomes 3 cubed x cubed plus, I'm going to distribute that squared to both of these pieces. So that's 3 times 3 squared x squared times negative 2y plus 3 times 3x times, and that's negative 2 squared y squared, and then plus negative 2 cubed y cubed. Next step, 3 cubed is 27. So we've got 27x cubed plus 3 squared is 9 times 3 is 27 times negative 2 is going to be negative 54. So that means we're going to do minus 54. So I've just taken all of this is a big term, right? It's a really big term. So we've got multiple pieces going on there. So what I do first is I grab all the numbers and I multiply them together. And then I'm going to grab all my x's, which is just this guy right here, x squared. And then I'm going to grab my y and finish it out. Plus, and I'm going to do the same thing with this guy. I'm going to grab all my numbers and multiply them out. So that's going to be 3 times 3, which is 9. Negative 2 squared is 4. So then 9 times 4 is 36. And then I've got x and then y squared. Negative 2 cubed, negative 2 times negative 2 is 4 times negative 2 is negative 8. So that's going to be minus 8y cubed. And that is your expansion. Okay, so this is how we're going to do notes. If you have any questions, please do not hesitate to ask them, to reach out, to send an email, to stop us in the hallway. We're more than happy to help. You're going to be seeing my face a lot for Unit 1, and then Mr. Serene's going to take over for Unit 2, and we'll see how this goes. I'll see you next time.